The foundation of one solution often inspires another. For example, Delta expanded during the jet age as flying became more comfortable. But direct flights between every city often meant half-empty airplanes. The old point-to-point approach wasn't working, so Delta drew inspiration from a wheel and simplified its network with a hub and spoke model. Delta chose Atlanta as its central hub. Several years later, Delta's model served as the inspiration for a FedEx hub. So the foundation of Delta's successful strategy was replicated by FedEx. In a similar way, MCP was also inspired by an earlier solution. A simple text editor can be used to write programs, but it doesn't come with any bells and whistles. Switching to a code editor unlocks special language features, like when you hover over a module name, you get a description. While you're writing an expression, you get autocomplete options and function signatures. Language intelligence features were historically implemented through editor-specific plugins. Let's use the Go language as an example. If we looked at 5 different editors, they used 5 different plugins to enable the language features. But that all changed with the launch of the Go language server. Microsoft created the language server protocol to enable a single server to be used by all editors. Communication takes place via remote procedure calls that use JSON as a data format. I'll use a VS Code example to explain. Put the cursor in front of the flip function and press F12 to go to its definition, and the editor opens its file at the spot where flip is defined. So let's see what happened behind the scenes. JSON-RPC defines these 4 keys for a request message. The F12 caused this request to be sent to the language server to invoke the definition method on the code in this file at the spot where the flip function is called. The server replied with this response message, which is linked to the request via the same ID number. The response tells the editor to go to the utils program at this location in the code. Similar to how editors once needed custom plugins, AI assistants once used custom connectors like this example for accessing data from GitHub. But after Anthropic created MCP, all the apps could adopt the GitHub MCP server. An MCP server provides context to AI apps by injecting data and the output from tools into their context windows. Does this architecture look familiar? Just as LSP allowed editors to abandon custom language solutions, MCP enabled AI apps to standardize their external integrations. MCP and JSON-RPC are not software. They're rules that enable apps to exchange data. Claude Code is an example of a host that manages a client which connects to a server. The client requests context from the server that the host can use. MCP defines the specification while software provides the implementation. Here's an example of an MCP server described via a web page. The server's URL is given, so clients can send requests to it. Like we saw earlier, JSON-RPC defines the envelope structure, and MCP defines the semantics, like the valid methods and their parameters. Here, an app is asking for the forecast at a location in New York City. Like before, the ID value at the top of the response ties it back to the request. And when we page down, we can see the forecast details that were sent back to the model's context window. When you see the MCP architecture, it may remind you of an API, but they are designed for different consumers. MCP doesn't replace APIs. In fact, an MCP server often calls APIs under the hood. The MCP server acts as middleware. It translates the simple request format, handling API details like endpoints, authentication, and retries. When an app is being developed, logic is hard-coded about when to make each API call, which method to invoke, and what values to pass. And the API client hardcodes endpoints, parameter names, and data types. With MCP, a client sends a request to ask about capabilities, and the server advertises what it can do. Here's the request to ask for a list of available tools, and the response contains details about each tool. The first one is named Get Forecast. The model will read the description and decide whether it should call it. Here's the full description, which a language model can reason about. It states the tool's purpose, its output, its scope, and its parameters. I'll close with a page from MCP's official documentation, which compares MCP to USB-C. Remember when we had a box full of connectors because there wasn't a single standard? After devices adopted USB-C, they communicated without specialty connectors. With MCP, all apps can easily query a database like Postgres or use a tool like Google Maps to search for places using text queries. I hope you now understand how MCP easily adds context to language models.